Okay, I want to show you just a couple more ggplot things just to give you kind of a high-level tour. One other cool thing you can do is you can generate subplots. You can separate out your data into different panels according to one of the variables in the data frame really easily using facet wrap. So each of these is called a facet. So it's the same plot as this, basically, just having the different classes of car on their own scatter plot. So you can see here, we're still plotting ggplot k equals mpg. That's the same. We're still doing a mapping with g on point, x equals displacement, y equals highway. That's still there. But now we're adding another layer called facet wrap. And we're saying, generate different facets, and what do I want each of them to be defined by? The class of the car. So instead of coding the class of the car in color, I'm assigning them to different facets. So now two-seaters, compact, mid-size, minivan, and so on, they have their own scatter plot. And the n row equals 2 simply means I want 2 rows of those facets. You can play with that number and see how it changes the ordering of them. So that's a really fast way of generating different plots depending on the value of the variable. Facet wrap just creates a list of different facets, basically, according to that variable. There's a different way to do facets called facet grid. For facet wrap, you give it one variable, in this case the class of the car, and it generates one facet for each value of the car class. If you use facet grid, you give it 2 variables in the data frame, in the tibble. So in this case, I've given it the drive, train, and the cylinders variables. Drivetrain is whether it's front wheel, rear wheel, or 4-wheel drive. Cylinders is the number of cylinders in the engine. And there's a little squiggly line in between. Anyone know what that squiggly line is called? Yeah?
Tilde?
A tilde, right. T-I-L-D-E. So drive, tilde, I just call it squiggle. Drive, squiggle, cylinder. And so now it has the drive on the vertical. So that's 4-wheel drive, front-wheel drive, rear-wheel drive, and cylinders on the top as different columns. So that's another way of doing these facets. This is kind of how I remember it. Facet wrap is just a list of one variable and its different values. And for facet grid, it's kind of like a 2x2 design, where you have one variable and another variable, and for each value of one, you have every value of the other one. And you want to order your facets like that. That's facets. We saw geom points, where you just say, I want displacement on the x, highway on the y, and you get points. There's another kind of geom called geom smooth, which instead of generating points, it generates a smooth estimator of the data. Kind of like a nonlinear regression. And I forget what algorithm it uses. It's some kind of like a piecewise polynomial or something like that. It tries to generate a line that's allowed to wiggle a little bit in the data. And it produces, I think those are 95% confidence bands around the line. But you can look it up. You can generate both by just using the plus. So I want geom points, plus I want geom smooth. I want them both on the plot. And in fact, ggplot is organized so that you can just keep adding stuff. You can keep adding layers to your plot, whatever you want. You can even add a different data set if you wanted to. Now, notice something. What do you notice about that code? Those 3 lines of code. Does anyone notice anything particular about it? It's not a tricky question. Yeah.
They're like the same except for like.
Yeah, that's what I'm getting at. Is there's duplication. This mapping command, mapping equals AES, X equals displacement, Y equals highway. It appears in geom point, and it also appears in geom smooth. Now that's not a bad thing necessarily. It just means that I'm telling geom point what I want on the X and Y axis, and I'm also telling geom smooth what I want on the X and Y axis, and they happen to be the same, but I'm being really specific. But there's redundancy there in this case because they are in fact the same. So what I can actually do is I can move that command out of these geom layers and into the main ggplot command. And I'm showing you this because as you travel, as you go on in your RStudio ggplot travels and you look at code, especially on the internet, you're going to see this kind of code, and you're also going to sometimes see this kind of code, where the mapping part of the command is not in each geom, but it's in the main ggplot command at the very beginning. And which is right and which is wrong? They're neither right or wrong. They're just different ways of doing things. In this case, where they happen to be the same, arguably this way of doing things is more efficient. And essentially what this says is, I want to make a ggplot using this data set, and for everything that follows, what I want on the x-axis is displacement, and what I want on the y-axis is highway. And then every subsequent layer I add is always going to assume that's on the x and that's on the y. And then it makes it a bit more readable, I suppose. Then you can just say, and now I want some points, I want a smoothing line, and you can just keep adding things without having to specify the fine-grained details. So, depending on what you want to do, that way of code you might come across. Now, if I wanted to have different points and different lines according to the drivetrain, four-wheel drive, front-wheel drive, rear, I can put that command all the way up there, because that applies to everything that follows. For both the points and for the lines, I want the color to be coded by the drivetrain. And then that automatically gets applied to both of those things. Does that make some sense? So, yes?
Just curious, is there a way to more specifically specify the color scheme? So, for instance, one is instead of green scan for four-wheel drive.
Yeah, so the question was, it's generated kind of red, green, and blue automatically. Is there a way to specify the particular colors you want? And I need a code for the general kind of answer to this kind of question. The answer is yes. The follow-up question, exactly how do you do that? I don't remember. I do remember it's not difficult, but I don't remember exactly how. So yes, you can. Yeah. That book I showed you at the beginning, R for Data Science, you can probably find the answer in there. Other questions? Yeah.
So with the previous, there's multiple ways to do There's multiple ways to do the same thing.
Yeah.
And in previous courses, we had to do it the way that they showed us. So if you went online, so like, you have to do the colors this way. And then if there wasn't in the book a way to select your color, then you went online and have to resource that, and you'd be in trouble because you're not getting yelled at, but like you get off marks because we went online. Is that, are we expected to do the way, the primary way of the book? Or
my way or the highway?
Yeah.
No. So the question was, as with the cases with Python and in general with any language, there's always multiple ways of accomplishing the same thing. And when you get a question on the homework or on the exam about how to do something or how something works, are you going to get penalized if you do it a way that I didn't describe, or that wasn't in the notes, or that even wasn't in the book? The answer is no, you should not get penalized. if the question asks you to do something or produce some kind of graph, and you've done that, and the way you've done that happens to be different, that should be still okay. Yeah. I think if the way you've done it is different and for some reason is, I don't know, obviously inefficient or could be more concise or something like that, then the TA or I might give you that feedback, but you shouldn't get any marks from it. Yeah. Other questions? Okay, so I showed you how to move those things up into the ggplot command to generate, more concise code. Here's something cool that is useful. So for that geom_smooth command, the default, if you don't give it any arguments, is to generate this wavy line, this line that's allowed to wiggle around. And again, I don't remember what the algorithm is. Some kind of piecewise curvilinear or something or other. If you wanted to only do straight lines, then you can give it this argument, method equals LM. LM stands for linear model. So now it's generating those smoother estimates using only a linear model. And if you wanted to get rid of those confidence bands because they were distracting or you don't need them or you don't want them, there's an argument for that. SE equals false. Standard error equals false. That says don't bother with those confidence intervals. Just generate the lines. So you can see kind of how you start. You start with something simple. Maybe you can only start with geom_point. You plot all your data in the same color. Then you decide, I want some kind of smoother on it as well. And in fact, I want to split it apart by drivetrain. And in fact, I want straight lines. And I don't need those error bars. You kind of construct your plots gradually, iteratively, by starting simple and then adding some complexity to craft just the figure you want. And that's the way it's supposed to go. That's the way I do it. It's rare that you have some plot in mind and immediately you just generate the giant crazy command that generates exactly that. I mean, I'm certainly not that much of an expert with R to do that. Few people are. Much more likely is that you start with something simple and you gradually, iteratively tweak it to get what you want. And because this is in code, all this code is probably living in a script or an R Markdown file somewhere. Once you've gone through that and you have the 8 or 10 lines of code to generate the cool, customized figure you want, you can always regenerate that again just by running that code. It's always there and it's always going to be exactly like that. And if you want to tweak just one little thing, you know exactly where in the code to go and tweak it, and you generate it again. So it's reproducible and it's shareable. If you don't like this gray background, then you can add a theme command plus theme_BW, that stands for black and white. And if you go look at the R for Data Science book, there's a whole laundry list of different themes you can choose from. And you can also customize each theme in every way possible to your liking. So it's really a very extensible framework. Okay, so I've shown you a lot of different ways of generating scatter plots and lines. You can also generate bar plots. I actually don't want to spend time talking about bar plots. I can't imagine anything much more boring than that. So I'm going to leave that for you to go through. You can go through those slides on your own, and you can look at the book. So I'm going to jump to the end of this. There's so many options with ggplot to generate any crazy kind of graphic you want. The thing to do is to play with the code, see how things work, make use of the online resources. All those books are searchable. That R for Data Science book and the ggplot book is searchable, so you can find stuff deep in the book. The homeworks will show you a little bit more about how to build up different kinds of plots, and they all build on simple examples. The way ggplot is kind of sold, the way it's pitched by its authors, it's a grammar of graphics. And And you can describe any plot as a combination of a data set, a geom or a set of geoms, a mapping, and then all this other stuff. And so this code here is kind of a general framework of thinking about how these different elements add on each other. But you can look at that later. Work through chapter 3 about data visualization and read chapter 4. Next week we're going to talk about transforming data, filtering data, selecting different columns, generating summaries. And how to look at this ggplot2 book. It's a much more detailed deep dive into ggplot than is found in R for data science. But it's where you'll find the really esoteric stuff about how to generate anything you want. What else? Here's some other good, really useful resources. If you click on these, it'll take you there. There's a ggplot2 cheat sheet, which is kind of like a big one-page thing that has like 95% of the commands that you'll probably use. So it's a good reference thing to have around. There's also a website called the R-Graph Gallery, which is kind of a visual index. Each of these little circles is a different kind of plot. And when you click on them, it'll show you the code that generates that kind of plot. So if you have a particular kind of plot in mind, you can go there and find something close, look at the code, and that will give you a good starting point for how to tweak that to generate what you want. Homework, that should say homework 1. Sorry, I'll change that. Some of the answers are directly in the slides, some are in the readings, and some require you to apply what you've learned. But the TAs are there to help you. They're not there to literally give you the answer. For the lab components, they are. For the lab components, they will take you through each question and show you a sample solution and talk about how it works and answer your questions. For the home portion, of course you can ask the TA or me questions about it. But you shouldn't ask questions like, is this the right answer? Or tell me how I would do, X. That's the point of the homework. So do your best. And yeah. What else? Oh yeah, always plot your data. Always remember that dinosaur. When you read news stories about science and they report a correlation coefficient or they report means or something, and they don't show the data, always be skeptical, because you don't know whether there's a straight line or whether there's a dinosaur. Essentially. Okay, final questions. Otherwise, your next job is to go and watch those videos about how RStudio works and do some of the readings and have a look at the homework and go to the lab. Oh, question here. Yeah. Oh, are you allowed to do the homework with other people? How should I answer this? Yes. Yes. Well, let me answer it kind of, just pause one sec. So the question was, can you do homeworks together with other people? Can you work together on the homework? So I think that's a really great idea. It's a really good way of learning is by doing something together with someone else. If you were to do homeworks in pairs or in groups, and then everyone literally copies one person's code and sends it in each week, I would have known. Your TA you get your grade, but at the end you would not have learned much. So I wouldn't suggest doing that.